If you want Pyro playing back in Unreal with good frame rates, hopefully this video will help you out. The issue is that volumes can be really heavy and take up a lot of space that would prevent them from being used in a real-time application like Unreal. So in this video, we're going to take a look at Zibra AI's plugin for Unreal that'll help solve those problems. We'll also take a look at how we can process volumes in Houdini to give them a better look inside Unreal. We'll start in EmberGen with a simple smoke sim. I'm only exporting out the density field. I'm exporting it out to Z up left-handed, which is perfect for Unreal. Amit Baril made a great diagram showing all the different coordinate systems for different 3D software. I refer to this page all the time. I'll leave a link to it in the description. In Unreal, I can go to Tools, Zibra, Import VDB Sequence, put in the file paths, click Compress, and let it do its thing. If you click on the asset, you can see the original size and how much it was able to compress it. In this case, it was originally 115 megs. Now it's 26 megs, compressing it down 35 times from its original size. Drag the smoke into the scene and we can see it play. What if we wanted to have flames coming off the skull? I'll go back into EmberGen, go into the emitter, and turn on fuel emission, and turn off smoke. Now I'll make sure that I export out the flames. I'll export that, giving it the file name Fire. Inside of Unreal, I'll go to Tools, Zibra VDB, and then Import VDB Sequence. I can see this was 577 megs, compressing it down to 22 megs, which is 39 times smaller than the original. I'll delete the smoke and then add the fire, which will give me the same result I had inside of EmberGen. Notice that the fire is not emissive. This is a big difference from Unreal's volumes. Zibra VDBs don't emit light into the scene. In this example, I'm just going to fake it with a light. I'll add a light to the level and then set it up to be a warm light to fake the look that the light is being added to the scene. What if we wanted to add fire and smoke? Something to keep in mind is that what we're used to in offline rendering is that the fire should affect and light up the smoke. Here's an offline render I did using Karma in Houdini, and notice how our fire is scattering light inside our smoke. If we don't have our fire light up the smoke, then the density of the smoke can just block the fire, and we can get something like this. What we want to try is to fake the scattering of light inside our smoke. In EmberGen, I'm going to go to the Simulation node and then the Combustion tab. And there, I'll go to Generated Smoke and turn that up to about 40%. This will emit smoke from the fire during the sim, not just from the emitter. Notice that in EmberGen, we don't get the fire lighting up the smoke by default. The smoke will just block it. EmberGen does have some settings in the shading node to try to fake this, but I'm just going to export this out. I'm going to export out density, temperature, and flames for Unreal. Inside of Unreal, I can remove the fire in my scene and then import the fire and smoke VDBs and then compress it. This will bring in temperature, density, and flames. The sim was originally 2.5 gigs, and now will only take up 39 megs inside of Unreal, which is 47 times smaller than the original. I'll bring this into my scene, and this is what I get. I have control over my smoke, flames, and the temperature field. If I look just at the smoke, it's not currently being lit. I need to add a light to my level to see it. Note that Zibra only supports a few different types of Unreal lights, like the point light or the directional light. Now if I turn up the fire, we can see that there's no interaction between them. I can go to my temperature field and then add in a little bit of contribution. But I find that this lights up the smoke pretty evenly, making it look a bit flat. If we keep it subtle, it can add a bit of a glow that goes through my smoke. Zibra does have an emission masking option that will use the density to act as a mask against the emissive volumes. We can play with the mask's intensity and softness to give us more details, but I think we can do better if we modify these fields inside of Houdini. Inside of Houdini, we can import in the VDBs that had the smoke, fire, and temperature. When we first bring it in, it's not being visualized correctly. We can use a Pyro Bake volume node to fix this. The orientation is not set up properly for Houdini since we exported this for Unreal, so I can rotate our VDB 90 degrees and scale it in Y to -1. The Pyro Bake volume is set to only show the density by default. I can turn on the fire, but it won't display correctly. We need to go to the Bindings tab to make sure that it's looking at the correct field. We can tell Houdini to use the Flames field that we exported out of EmberGen. This will give us the same thing that we had in EmberGen, where the fire isn't affecting the smoke at all. Let's turn off fire and turn on the scatter field. This should give us the ability to create the internal scattering look, but keeping parts of the dense smoke solid. We can play around with the blur controls, which will make some of the smoke stand out more. Then I can play with the masking controls to reveal more or less of the smoke. The mask center is affecting the amount that's being masked off, while the mask width is making the mask softer or harder. Now I can add back the fire to get the entire look. Don't forget that we can control a lot of these intensities inside of Unreal. I don't need to dial in my final look here. To separate out the different fields, I can use a blast node, select the density field, and then check delete non-selected. This now will keep only the density. The visualization might get messed up at this stage, but this is just temporary. Then I'll get another blast node and then delete the flames, which deletes them, but then I can select delete non-selected to keep them. The last part is the scatter field. I'm going to duplicate the Pyro Bake volume node and then go back to the bindings tab. In here, I'll select Bake Emission Volume. This will store the scatter field in a field called CE. If I use a volume slice node to visualize these fields, notice that the scatter field is very blurred. It doesn't contain a lot of the information and detail that we really want, but if we visualize the CE field, we can see way more detail. The CE field contains the fire and the scatter by default, so I'm going to turn off the fire checkbox so I'm only left with the scatter information. This is why we duplicated this node, so I can leave our fire alone and just have this node just for the scatter field. The next thing we have to do is break down this field. The scatter and CE volumes are both vector fields. This means that they have 3 fields combined into one. Zibra's plugin can't currently handle this, so we need to split them out into 3 separate fields. We can use a VDB vector split node to do this. I can select the CE volume, and now I'll have CEX, CEY, and a CEZ field. The CEX field contains the most information. I'm pretty sure it contains all the red information of our scatter, so I'm just going to use this field in Unreal. I can merge our flames and density nodes together, and then use a volume visualization node. You just have to type in the name of the field that we want to see, and density is already there by default. In the emission tab, I'll type in flames, so that it will use that field to visualize the fire. Then I can turn up the emission scale, and that will give me a preview of how the fire and smoke should look in Unreal. After the vector split node, I'm going to use a blast and keep only the CE field. Then I'll use a name node to change the name of that field to scatter. Now, if I connect this field to the merge and remove our fire, and then set the emission tab to look for the scatter field, we should be able to see the scatter field start to appear. Now I can merge all 3 fields together. Before I export, I can see a lot of attributes on these fields, so I'm going to delete all of this just to keep our geo as clean as possible. Then I can use a ROP geometry output node and write out my VDBs to disk. One thing I almost forgot is that I can copy my transform at the top of the setup and bring it to the bottom, turning on invert transform. This will put our geometry back to its original position. Now I'll write this out and open it up in Unreal. Inside Unreal, we can import in our VDB sequence like we have before. We can see that it's reading in our density, flames, and scatter fields. Hit compress to start the compression process. Once it's complete, open up the asset and make sure that all the fields are assigned to their correct channels. You can see that our temperature channel is empty. Originally, this was just over 2 gigs. It compressed it down to 45 megs, which is 28 times less than the original. At first, this might look a bit ugly, so I'm going to turn off the flames and temperature and just deal with the smoke. We can go to the temperature and then start to add that in a little bit. Then we can add in our flames just a touch and see how that looks. We can play around with the intensities to make sure that we're getting this just right. Here's a comparison. On the left, we have the density, temperature, and flames directly from EmberGen. On the right side, we have the density, flames, and the scatter from Houdini. While we can't render with path tracing in real time in Unreal, we can try to process the volumes in Houdini to try to get a more textured look. Zibra is also working on this plugin for use in Houdini directly. That's out in beta now. The labs team just made a video about it, which I'll put in the description.